Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today, I would like to make a video just for you all. I'm scared that you may not understand what is in our manual. So, besides that, you must also read this one, okay? For example, page 17. 17 and 20, okay? But as you know, this lab is the most safest lab. I told you before, because the SOP coming into the lab is so strict that you need to follow some procedures just to make sure that there is no contamination in the lab. And then I think I told you about nothing in the pens unless they must be labeled. All our culture are put in the refrigerator. For today's video, I would like to make like 3 parts. One is we go on tour and we'll show you what are the basic equipment that use in a microbiology lab. And the second one, I want to show you how to prepare a media for our heterotrophs microorganisms from the soil. Okay, I'll give you just one example. There are lots you have to prepare. For example, the NA, SDA, RBC, TSA, and Ramsey. But today I just prepare you the normal, the non-selective media, that is NA. To compare, if you prepare like Ramsey, a bit of selective media, that it is actually we use Ramsey for enrichment to isolate hydrocarbon bacteria. So we just prepare how to then the third one, I will show you how to do the dilation plate technique. If you want to do, after you, from the soil sample, we want to know the microbial population in the soil, then we have to do the dilation plate technique. So let's go and to the lab. I'm here with Asmadi. You know Asmadi, okay? And then this is a typical display refrigerator. It is 4 degrees Celsius. So any sample that you collect, or after you do the work, you try to preserve them, you put in this display cabinet. So most of the things these are either doing FYP or the postgraduate students. Our labs are not like research lab and teaching lab. They are both combined. We do research and teaching lab. So this is fume cabinet. When you do volatile compounds, you have to use this in Malay, kubuk asap, okay? Kubuk asap. So you have to prepare here all your things. Or you want to prepare some solvent that is volatile. You have to prepare in this cabinet. We have the incubator. Yeah, we have some. This is our incubator. So this they set it at 30 degrees Celsius. Yeah, so we have quite a few of incubators. So most of the students will put like 30 degrees, 37 degrees, like 40 degrees. They will set up all the temperature themselves. They can also share if the sample they need to incubate at 30 degrees or 37, whatever temperature they need. This is our wet water bath shaker. So sometimes you have to use, sample you need to shake, so you have to use it. And over here we have a normal refrigerator. The same, it's 4 degrees Celsius. Usually we have, like, all our culture must be kept in the refrigerator. You cannot, if you, like this one, I ask them all the culture, the live culture, they prepare here. And then sometimes they may have the freezer, what they require. Then Of course, this refrigerator always kept in order, clean, and all the specimen inside must be labeled. No specimen allowed in the lab unless they got label. If no label, then our staff, our lab technician will collect them, put them in the bag or in the blue bag, autoclave them before they dispose. Then we have our cabinet where our basic glassware and some medias as well. And this another one, another cabinet, the film cabinet. This one they use to, if you want to do like extraction or this one is the heating mantle. This is the heating mantle. Yeah, this is got 6. Then but heating mantle you have to put in the film cabinet as well. And then these are the pens for the students. Usually our FP students, they will select one, like they share this one like 2 students. What was that? Yeah, they are same. They are incubators. This is our desiccator. Desiccator means is to after you dry, you put in the oven, you put them to cool them on in the desiccator. And we have freezer as well. If you have sample, we put under freezer. So that is this area is very sterile. You have to wear your lab coat, your own lab coat usually. Lab coat, and the shoes also we prepare. And then if you see this mat, this tacky mat, where your shoes will be if you wear your shoes, all the dust will be put there. So from time to time they will just change this. They will just peel it off like mahjong paper. Okay. And then here, we got we got 2 safety cabinet, okay, or sometimes we call it a laminar floor set. So usually you when you on, you light on, and then you have the blower. They always work. This laminar floor is the heart of this lab, because anything you do, you must be sterile. You must always be inside the and then we have usually we have always put a flame, flame that we have gas and flame. And then every time you use, before you use, you must spray, like doing the sanitizer or the alcohol 95% or 75 or 95%. And then you have to mop with the tissue paper, the sterile one. And then after you have done, you off all this thing, and then you have to clean it again. So you have to clean them before use and after use. It's a must. Okay. From time to time, we also need to use this one. We don't have the UV. I think and the other one, I think we have the UV. Yeah, this is a good. So we have blower. This is the light. So this you have to, all your things that they're all sterile. Then you do your work here. Okay. So you have to clean them before and after. There's a time like you want them to be really sterile. So you put the light UV, but you have to shield in front of this, and then you have to, the room you lock, nobody can enter when the UV is on. Okay, this is the basic micropipette. Okay, this is the centrifuge. Yeah, centrifuge. This is our basic spectrophotometer, like students want to do the microbial population, the OD, and then they have to use the spectrophotometer. And then yeah, we have two spectrophotometers, and this is the culture. They are not supposed to be here. They're supposed to be in the refrigerator. Okay. Then we come to here is the washing area. We have incubators, they have pods, and then this is the shaking incubator. Is it? Oh. This is the shaking. So this is one of the shaking incubator. You can set what's the temperature you need. Okay. So this is how actually it will shake, and then with the correct temperature. Why is not shaking? No. So this is so they will wash here, and this is the students, the postgraduates cabinet. They have their own cabinet. They make their own key. Okay. This is the. I'm not sure whether the autoclave. All the glassware, the media, you have to autoclave because we want them to be free of microorganisms. We don't want, our experiment will be like, in fact, contaminated from other environment. So, all the glassware, the media must be autoclaved. And this is the no lights. Actually, this room, I cannot find the light. Actually, this room is a cold room. All samples you collect, you put here in a cold room. It's just like a refrigerator, a bit. So everything. No, what's that? No, sorry, the light is not working. So it's okay, we skip this. All the samples after then you put them. And this room is the microscope room. All the microscope are here. They have their own like their own casing where they control the temperature. We don't want usually in a microscope the problem is like molds grow on the lenses. So we have to keep them under this condition. So, but every equipment used in the lab, they have their own logbook. If you want to use whatever, so they have their own logbook. You should put your name, the time you use. So this is the end. This is my favorite room. This is a media room, media preparation room. So these are all my media that I did. So we prepare the media here. This is the balance, and this is the distilled water. We have to make our own distilled water because you use a lot of distilled water in this lab. So at night they will sometimes sleep here because doing microbiology you have to stay at night. This is the last part of the. So we have here some of the glassware we wash here, washing, and then this is the autoclaving. We got two autoclaves. Okay. Or the on kari. Oh. So this is, but this is the where you put your media or glassware. You have to put in the basket before you put in. So actually, you make sure that it's all clean, and then there's a water. Yeah, this is not very clean. It should be like very clean, and then always have water. Just it goes into the, the hole there. So make sure that there's a water before you put all your things. So you know what the autoclaving is? They will do it for, they said the normal 115 degrees Celsius for 15 minutes. What happens is it like from 35 it takes some, it doesn't mean in 15 minutes they will go, no. It 115 degrees Celsius 15 minutes. When it reaches 115, it will stay there for 15 minutes. So then slowly it will come down. You can set them, and you cannot go down before like 55 degrees, because if you go to the media, you must, when you pour, it must be like 55 degrees Celsius, so it's easier to pour the media in the laminar flow. And then this is our drive. I think that's it. So usually, like when they have dirty things, they will soak them and put them in a basin overnight with all the soap, all these things, and then early in the morning before they come to the lab, they will clean them up. When it's clean, they will dry them, and then they will use it for, and then when they want to use it, they will autoclave them. Usually in a lab, we need at least two. For example, one is for only waste, the culture or the waste, and the other one just for glassware. That will be, it will be clean. You don't mix, unless you have no choice. Then you have to, when you do the waste, just waste, and then when you do the glassware, the clean glassware, just put in this basket the glassware. They can do 2, 3. Boleh masuk tak? Boleh masuk berapa? 3? I think 2, 3 biasa. Yeah, usually it's 2. Yeah, it's two baskets can put in at one time. I think that is parts of the tool. You saw the cabinet. Remember I told you when the UV is on, you seal them. You seal the whole. Then you close this. So that maybe usually people do for overnight, but 3 hours, then you put this, nobody can enter the room. Okay. I think that's it. We put some of the this is some of the experiment we do, strip plate technique, and this is it's all in your handbook. All this how to do it. Then this is the booking biosafety. I think that's it. Okay. Okay, now we want to do how to prepare the media. You read this on the page 20. The preparation of media is like one day before we go to Tenom to do the porous biodiversity. Remember in our video we collect a soil sample. Then to isolate some bacteria from the soil. And then before you actually, when you do the sampling, you prepare your media first. There are how many? One, two, three, four, five. There are 5 media you're supposed to prepare, but I just show you 2. The normal media, the non-selective media. You can any bacteria can grow, and then the other one is the Ramsey. First, I will prepare you the simplest one. So it says if you want to prepare 250 mil, then you have to suspend I think this one is too big. Ada kecil. Actually, for the NA, you don't have to like stir with the heating. You just so they say how many 200. Yeah, 5 grams to 200. So prepare 5 grams. This is the before using a balance. There's the one thing you must really do. Make sure that you know this one. There's a label. I don't know what you call it. You must make sure that the bubbles are in the middle, just to make sure that these are really, horizontal. So the balance will like if it is not in really horizontal, so it will affect the quantity or the reading, how much you put in. So I just show you. So this is actually this analytical balance. You have 2 doors. You can open just one door, and then you put the like the what is that small plate, and then you zero it. So it is 0, and then you take slowly. You do like 5 grams. Yeah, it's 5 grams for. If you this is 5 grams for 250 mils. You have to do it slowly. Okay. Until you got the. You can show the scale bit. Yeah, it's just like baking a cake in your kitchen. Make sure your this media are not expired. All these things. Always check. Make sure they are all not expired. That is why in the lab they always inspect when expired, and then they have to use it before expired. So can you see the scale? That's why in the microbiology lab, men doesn't like all girls, because the hands are very steady, not like you see they are more like pipe, so you can remove a bit. So more or less like try to be precise as much as you can. Oh. Yeah, it's more or less like, you can see that it's more like a pipe, right? So you can, so you take that one. So this is your, I think this is 1 liter. you can have you don't have to stir all this thing, and then you can 250. This is 250. Well, if it is 1 liter, so 5 grams times. So you can have to times how many, like 20 to 20 gram about 1 liter. Yeah, I think so. Okay. Then if you need to 250, don't put all the 250 at once. You know why? So there are a lot of mistakes. They put everything, and then when they pour this is how you pour. Okay. No, you just do like that. What happens is if you put all the 250 together there, you don't have water to rinse. You have to rinse your small, what you call it, small plate, or I don't know. So you have to rinse them there, and then at least twice rinse, because sometimes the media stick into your face, and then when you are okay with that, put it aside, and then you pour everything. Okay, you pour everything. NA, you don't have to stir it, all this thing. You just, where's the cap? Put the cap, okay, and then we just shake it. Okay, you just shake it. We just leave it like that. I will show you. Put into the basket. They minta satu basket tu. Okay, we don't have to. When you autoclave, it will be all homogeneous for this thing. So that is the simple medium. So we go to the next one. So that is the Ramsay consists of what? In your 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Like 6. Okay, like 6. Ammonium nitrate, or the thing there is all there. Okay, I just show you like the first 3. Okay, Ramsay. You at the same time, at the same thing, you have to weigh each of the medium. For example, I already weigh 3, as just now, just like just now. So the problem of Ramsay is you have to stir. See, especially when you prepare the broth, it should be like clear water. But when you don't mix them well, they'll be like very cloudy. So it is not a good mixture. Even when you do autoclave, it's still the same. So that is why you have to. So put your bottle there, and then where is my? So this is 1 liter. 1 liter means 1,000 mils. So you put like first you put like 300 first. Remember I told you don't pour everything. At the end of the day you don't have water to rinse your plate, your small plate. Yeah, you can. All distilled water, everything is sterile. Okay. No. After that you will autoclave them. So this is your magnetic stereo. Okay, this is the rod. So you put that, put in the center, then hooks. This is then you on the you can see. Yeah, it is. If it is not doing well, then you can until it. Yeah, that's good. And then you put all your media one by one. So this is the first ammonium nitrate, for example. You where is the? You put your one to you. Yeah. you put your ammonium nitrate according to the amount you need. Okay. Okay, what's that? Okay. Make sure it all dissolve. Sorry, this is the water. You have to rinse. You can rinse like, yeah, you swirl a bit and then put there and then make sure you all the 1000 ml enough for the 6 to put in, and then you rinse your things. Okay, so then you see that everything like dissolve. Everything dissolved. Then when you are satisfied they are all dissolved, then you put the next one. Okay, let's say same thing. Okay, and then you rinse. You swirl a bit and then you rinse. Then make sure that everything dissolves. Don't put the next one before it all dissolves. It will come like cloudy, not a clear water like this. Yeah. I think that's okay. Then you go the next one. Okay. This one sticks, and then if it sticks, you rinse. Okay. You rinse them. You swirl a bit so that everything. Because preparing a media, you must have the correct amount of each. And because in the media you want to make. Okay, so continue with all the 6. Then the 4th one, when you go and weigh them and put. I think the last one will be the yeast. It's 0.06. So everything. Let's say for example you have done that. You put everything there. Then you put after everything inside, and then it's all clear. Then you put all your distilled water inside it. Then it comes to like, yeah, it will becomes like this. The 6 chemicals inside there, and then it's all. It looks good. Okay. I'll just show you. Don't forget, I just show you the 3. We can do everything, and then after that you are satisfied that it's all mixed together. Then you see the media. You don't have to heat unless the media said you must heat. In the label you must heat, but usually you don't need to heat while you are stirring. So off the stirrer. Okay. Then remember you have to take back your stirrer. Don't autoclave the whole thing with the stirrer. Okay. Then you got this there, and then you put there. So you got your. So this is the 2 media you prepared. So everything you put in this basket, or make to put. Actually, you autoclave. like you got everything like full two baskets together. You can put another glassware or things. So when you make sure that when you put into this basket, you loosen a bit the cap to have a good autoclaving. You loosen a bit, okay. You loosen a bit the cap, and then that is you put you to the autoclave. That's it, okay. That is how to prepare the media. So nowadays media, you have like NA, it's all ready made. There are lots of chemicals inside. They have ready made, commercialized, and then you just buy. But there are some media you have to prepare your own one by one. Okay, like the Ramsey. Okay, like the Ramsey, you have to prepare. Okay, okay. This is we are trying to explain the soil microbiology practical, like on page 17. So you have the technique is a plate dilation technique. Okay, for example, we have prepared all the media, the TSA, the RBC, all these things. Now we want to do the dilution technique. You have to prepare dilution. You know why? If you take directly from the soil, you don't do dilute. You cannot count. You cannot count the bacteria. It's too numerous to count. Okay, what the thing is, let's say 10 grams of soil mixed with 100. Okay, you mix that one. This is your, okay, you got your soil. This is your stir. You stir it. So actually, easily you can you do this in the LaminoPro better. So that your sample no contamination in it. So you do in the LaminoPro. So the flame is in the middle. So you prepare all this. So you stir this. Let's say what he said is like to set up or, okay, if you are satisfied. Okay, you don't have to wait for 15 minutes. Okay, you imagine that. Okay. Actually, when you take this is in this bottle dilution, you have 9 mils. Okay, this one is already autoclave. It's sterile. You have autoclave them. Usually, it's in the cap is with aluminum cap. Okay, when you do the sterile. So let's say you have removed the aluminum, it's already sterile. It's all sterile. And then there are 9 mils. Every bottle have 9 mils. Or if this is the universal bottle. If you use Bijo bottle, like that is a small one, you can put 0.9 mils, and then you put 0.1 from here. Okay. So what happened is, I'm trying to. What happened is, where is this one? Ini? Okay. So what happened is, we have the 100 mils. Okay. Then we take 1 mil here, okay, from the original sample, and after that, from here, so it will be, this will be 9 plus 1, right? Mil. Because it contains all together is like 9 mils. Okay. So, and then then you share a bit. I will show you later. Then you take from here 1 mil. Okay, and then you got your things, and then from here you take 1 mil, put here 1 mil, and then all together like that until you reach. Okay. Yeah. So put 1 mil and then you 1 mil. So all together it will become like all this one until you got all the dilution. Okay, you got the dilution. But when you do your plate, your put, then you take. If you do the plate, say you got. Usually we do duplicate. Okay, the medium. Let's say you do TSA, medium, or the TSA. Let's say for this one, forget what is written there, but usually when you do like for microbial population or this thing, you only like the best one, you do this one, 10 power 4 to 10 power 6. So like easier to count. Okay. For example, when you do your CFU per mil, let's say you do CFU per mil. So that you do the formula is number of colonies times dilution factor times inoculum factor. Remember that the dilution is the dilution factor is there, from which, and then the inoculum factor is you put 0.1 mil right into the media. You put this one, you go inside this. Let's say from here you put 0.1 mil. 0.1 mil. Usually you do duplicate, easier. Okay. Then after, let's say you incubate this one for 24 hours. For 24 hours, let's say at 30 degrees Celsius. After 24 hours, then you can count the CFU. So let me show you how to do it. Usually we do this on micropipette, okay? It's the sterile micropipette with all the tips. But today I just show you with the tip dropper. Okay, let's say it's sterile, then you must be in the, you flame it. You should be in the what we call the safety chamber. Okay, for example, this is the flame. Okay, this is the flame. So you walk under the flame. Okay, always. When you open it, then you there's a flame. You flame it. You know what? Up you must see when you open, you flame it. Okay, and then you take. This is 1 mil. Yeah, it's a micropipette. It's easier. So you take. Let's say this one is what? This is 1 mil. Then you put there. Make sure that the tips or anything doesn't touch the corners of the bottle. Then you put there all together. Okay. Then you rinse it. Don't touch the edge of the. Okay. So you got that. Then you go to the flame. This, for example, this is a flame. Okay. Then you close it, and then you swear. This way. If you got a vortex, it's okay, but it's okay not to vortex. Sometimes you just swear like that. Okay, and then if you do micropipette, you get the tips, and then you can. Let's say if you use this one, don't use the same. What is this? And then yeah. So you use another dropper. Yeah, this is a dropper. You use another dropper. So you open again. You swear. Okay. Open. Imagine that you're in the laminar flow, and then you open this. You open. Okay. and you put there. Then you take like 1 ml. Okay, let's say 1 ml. Then you put there. Okay, then you rinse it. Don't touch the edge. Okay. Then you close this to the, and then close that. Okay. And then you close. You remember in the laminar flow you got a flame. You have to open and close. You have to play. Okay. And then you swear again, and then you repeat like that until you don't have to go to like 7 and 8, like until 4, 5, 6. Okay, as an indicator. Like in your thing, if you do TSA only, yeah, you have to go to 8 in your, but then you have to go all together. You repeat the same until you got the sample all there. Okay, so then you do your after. So let's say you all do your sample already there. So you take, let's say 10 power 2. You take this one, take 2, and then for example 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. For example, you have done everything. So you take that one. So you take to TSA, do the same. You just take 0.1, put into the plate, the agar plate. Oh no, the Ramsey. Let's say TSA plate, the TSA plate. Sorry, yeah. Because as TSA is like a bit selective for soil microorganisms. So that is the technique. And then at the end of the day, you have to do the dilation technique. And then kita ada plate kan, ada culture. Macam di sana tu ada, never mind, ada kosong putih apa? Then after you incubate 24 hours, you see in your plate the colony morphology, okay, where you can at the same time, for example, let's say here your plate, right? So you got 2 plates there. So you have a lot of colony. This is the colony morphology. Okay. So maybe after, usually the soil after 20 hours you got a lot of incubation. So you can count number of colonies, okay, and then from here you can see you already number of colonies times detachment factor, include factor, you got the CFU. So this is usually this not a disposable plate. So let's say you have agar there, when you in the laminar flow you open, there are a lot of growth, okay. So in your assignment, I've given you the colony morphology. So try to describe them. We got the configuration, okay, and then you have the margin, and then you have the elevation, and then try to see the color, okay, or color, if you combine the size, and then see whether it's spreading in the plate or not. Okay. Sometimes they give like slimy very slimy. Okay. So that is the, after that, after you incubate, you can get the colony morphology. We don't do the other experiment, the cellular morphology, but I've given you the cellular morphology, okay? But I've given you cellular morphology, I've given you the colony morphology, and then we have tested so you have the moisture content, okay, and then the other one is pH. Okay, so try to see the CFU of effects of the environmental parameters that is pH and moisture content. Towards the CFU. Okay, I've given you all the data. You make your own. You can make your own graph. For example, this is the. Let's say you've got 6 plots, 6 soil. These types of soil. Soil 1, 2, soil 3, soil 4, soil 5, soil 6. Because you have 6 groups, so you have 2 axes. Maybe this axis is the pH. This is the CFU. Okay. Then the other graph or figure will be, you got the same S1 to S6. This will be CFU per mil. This will be the moisture. This one is pH moisture content. So you can see the effects of this temperature towards the micropopulation in the soil. Hopefully that explains the thing. Thank you.